All right, guys, I wanted to make this video to sort of go over a lot of the questions I received about Activity 3 in Investigation 2. So, um, on this first page, you're met with a question here. It's worded a little bit confusingly. It says, two positively charged objects, object A and B, are 8 inches apart. There's a positively charged ball that's hung in the middle, and at the start, the ball moves towards object B. So what can you conclude about the relative amount of positive charge on object A or object B? So we are starting with three positive objects. And we know from the past that if we have a positive and a positive, that they're going to repel. Okay, but in this investigation, we've been talking about how the amount of charge can affect those forces. So in this situation, it's saying that the ball, the positively charged ball that's hanging in the middle, is going to start by moving towards the positively charged object at B. So this would lead me to believe that the positive charge at point A is larger or stronger than the positive charge at B. Okay? It's being pushed towards B, so that tells me that there's going to be a larger amount of charge here that's going to create a larger force, a stronger force, pushing it away towards the B side there. And I wanted to get into a more in-depth explanation of what's going on with this Franklin's bells demonstration. So in the video, the Van de Graaff is sort of out of the frame, but there's a wire connected to one can, and there's a ball that's hanging in the middle, and then there's a separate can that is not attached to anything at all. All right, and if you go on to this third bit, I'm going to take a look at the video here. The link to the video is right here, and there is some important audio there to pay attention to. I'll go through here. At this time, the Van de Graaff is not on. The ball is hanging right in the middle. We can assume that everything is relatively neutral. And you can see that they take the Van de Graaff and they plug it in. Okay, so immediately that object that's hanging in the middle starts going back and forth. Now, an important thing to note here is that it's not just swinging back and forth in between the cans, but rather it's bumping into the cans. Okay, so we know that the distance between objects can be very important as well as coming in actual contact. There's a big difference between touching something and exerting a force on something without touching it at all. So I can see that with the machine turned on, this object continues to bounce back and forth. As she unplugs it, we can see that the pendulum comes still again. It's a little bit attracted to the free can. I'll rewind here. There's another sort of series of undulations as she touches that free can. Okay, so I wanted to talk more about what's going on with the charges. Okay, so to go through these questions, this is after the Van de Graaff has been running for a short time. The ball moves towards can 1. All right. So this question specifically asking about panel B. That's the one I just read. What causes the ball to move? We know the pendulum starts with a neutral charge. I can't spell right now. Neutral charge. And can 1 becomes charged by the VDG. Neutral objects will be attracted towards any charged object. Doesn't matter if it's positive or negative. Okay. Another important question, what can we say about can 1? Remember, can 1 is the one that's attached. Because it's attached by a wire, I'm going to assume that it is the same charge. When any metal, any conductor touches another one, they will become the same charge. Okay. The next question, what can we say about can 2 at panel B? Again, to scroll back up. At this point, this can has not touched anything. So we are going to say that can 2 is still neutral. It hasn't touched anything. What's the charge of the ball? It's still moving towards it. It has not touched it yet. So I'm going to say that that is neutral. Now it's starting to ask questions about panel D. The ball moves away from can 1 and swings towards can 2. What causes this? So if we look at panels C and D, in panel C, the ball is actually touching can 1, and in panel D, it's starting to move away. So the ball was charged by the can. They came into contact with each other, so they received the same charge. If one was positive, the other's going to become positive. If one is negative, the other's going to become negative. What is the charge on can 1 at the moment of panel D? Still going to be same as the Van de Graaff. It's still connected to the Van de Graaff, so it's still going to remain the same charge. What can we say about can 2? Again, it hasn't quite came into contact yet. So I'm going to say that this is neutral. However, when we're talking about the ball, it has already touched can 1, so it should be the same as the Van de Graaff as well. Okay, so the can 1, always going to be the same charge as the Van de Graaff. Can 2 has not touched anything yet, so it's going to be neutral. The ball itself, it touched can 1, which is touching the Van de Graaff, so it's going to be the same as the Van de Graaff. Okay, so what we should have seen, and I want to find a good image here. These will do. Again, the Van de Graaff sort of out of the image here. It's going to send these charges down, and it's going to charge this can. Because this is charged and this is neutral, it attracts this ball. Once it touches, this is charged, and now the ball is charged. So that's going to create it to swing. We could even take it one step further. We could say that once this ball hits the second can, now that can 2 is going to have the same charge as the others. So that sort of creates that swinging back and forth, and it creates that cycle where it goes back and sort of bounces back and forth between both can 1 and can 2. So I hope this helps understand. This helps you understand, what is kind of a complex demonstration, and hopes you understand a little bit more about how things are becoming charged and whatnot. So I'll talk to you guys soon.